having a problem that has two or more solutions so you can verify your solution. So here we have a question. Determine whether these 4 points are coplanar, meaning do they lie on the same plane? And there are 2 ways that I'm going to solve this problem. The first way, method 1, is called the scalar triple product. Scalar triple product. Okay, and here is what we're going to do for both methods. We have 3 vectors. Let the vector A equal AB, which is equal to points B minus A, 2, -4, and 0. Let vector B equal AC, which is equal to, let me think, 4, -3, 1. And let vector C equal AD. And this would equal 101. Alright, so the scalar triple product is V stands for volume equals A, vector A, with the dot product of the cross product of B times C. And the way you can think about it, the idea here is that these vectors form something called a parallelepiped. And if the volume of the parallelepiped is 0, then these 4 points are coplanar. So let's just plug in the formulas. The first thing I am going to do is find the cross product of B and C. So B cross C is equal to, and there's the formula for the cross product, I, J, K, you can even put these on, 4, -3, 1, and 101. And this is equal to I hat, here, -3, 1, 0, 1, minus J hat, 4, 1, 1, 1, plus K hat, and this would be 4, -3, 1, 0. And this would equal to, okay, so we have, for our I component, -3, -3, equal 4 minus 1 is 3, but this is negative, so -3 again, and K, this, plus 3, so 3. And this is the value of the cross product. So you have then A dot B cross C. So A dot B cross C is equal to, so take our A, 2, -4, 0, dot with -3, -3, and 3 is equal to 2 times -3 plus -4 times -3 plus 0 times 3, which is equal to 6. So the volume of this parallelepiped is 6, which is not 0. So therefore, these points don't line up on the same plane. The second method you can use is called considering the extra point. If you know 3 points that are on the same plane or 2 vectors that are on the same plane, then you can find the equation of the plane. And then we can consider the fourth point. We can plug that fourth point into the equation of the plane to see if it's coplanar. So let's consider the points A, C, and D. Let's ignore B for now. Let's find the equation of the plane these 3 points lie on. Now, the cross product of B and C, so N stands for normal vector. N is equal to the cross product of B and C, which earlier we actually found out that it was -3, -3, and 3. Okay, so now we have that, and we can use any single point on the plane to find the scalar equation. So let's just say -3, use point C. Let's use point C to find the equation. So it's x minus 1 minus 3, y minus 0 plus 3, z minus 1. This is finding the scalar equation of the plane using point C is equal to 0. And then doing some math and plugging it around, we have -3x plus 3 minus 3y plus 3z minus 3 is equal to 0. These 3's cancel out. -3x minus 3y plus 3z equals 0. And then we have x plus y minus z is equal to 0. For points A, C, and D. This is the plane where points A, C, and D lie. Now, consider point B. Now we consider the extra point. So B equals 1, 0, 3. So then x plus y minus z is equal to 0. Plug that in. So 1 plus 0 minus 3 equals 0. -2 is equal to 0. This is not true. So therefore, these points aren't coplanar.